Okay, so we are solving problem 77 from chapter 3 in Giancoli 6th edition. So let's start with the part A of this problem. What we have is a car that is up in a platform, okay? And this car wants to fly over 20 cars that are down here. If it succeeds, it will end up here at this point, which is 20 meters away, 20 meters far from where he starts the motion in the x direction. Okay. We also know that this height is 1.5 meters. And the question for this problem, for part A of this problem, is what is the initial horizontal velocity of this car. So this car is just going to go on initially on the horizontal velocity, and what we want to know is what is this Vx. Okay, so this is the question of the problem. Okay, to solve it, first thing I'm going to do is choose a reference frame. I'm going to choose as reference frame positive to the right and positive down. Okay, so this is the x and the y coordinates. With this choice, I know that g, which is always pointing down, is positive plus 9.8 meters per second squared. According to this choice, I also know that the initial position in x is 0, the initial position in y is 0, and the initial velocity in the y direction is also 0. This motion, this car starts only moving in the horizontal direction. Okay. All right, what we want to know is what is the initial, what is the velocity in the x direction, the horizontal velocity. So I'm going to go for the equation in x. X equals to x naught plus vxt. Let's see what we can substitute here. The final position we know is 20. The initial, according to the frame, is 0. Vx is what I don't know, so I'm going to put this in red. And the time, well, if I had the time, this problem would be done, but I don't have the time. So I'm going to use the motion in the vertical direction to try to find this time. And in the vertical direction, I have positions also. So I go for the equation with the position. Y equals to y naught, v naught y t plus g over 2t squared. What can we substitute? The final position is 1.5. The initial is 0 according to the frame. There is no initial velocity in the y direction, so 0. My g is positive, so I have here 9.8 over 2 t squared. So from here, you can find the time and then plug it into this equation to find the velocity in the x direction. So this is a constant uniform velocity, and so it will never change. No? So you just get Vx. Let's make this problem a little bit more complicated, and what we are going to do now is, instead of having just horizontal velocity initially, we are going to put this car in a ramp. Okay. This ramp has 10 degrees. And so now the question is, what is this initial minimum velocity that it needs to have to be able to cover all of those cars on the floor? Okay, so the question now is, what is this initial velocity? This initial velocity will have x and y components, so we have to be careful about that. The rest is very much similar. So what we have, this car is 1.5 meters from the ground, and we want to cover in the horizontal 20 meters. I'm going to use, so this is the motion. I'm going to use the same frame that I had before, where to the right is positive and pointing down is positive. Okay? This is x and this is y. So my g continues being positive. What else do I have? My initial position in the y direction, and in the x and in the y direction are 0. My initial velocity, that's what I have to be very careful now. My initial velocity in the y direction is not 0, and according to the frame that I chose, it is negative. Okay, so this is something we have to keep in mind when we use the equation. Let's start following the same thing that we had before. And what we had before, well, we started with the equation for the horizontal motion. So the final position will be 20. We know that. The initial is 0 according to the frame. What is Vx? Vx is the component of the initial velocity. So it's V naught, which I don't know, multiplied by cosine of 10 degrees. Okay, this is just a number. You can just put the number there, and t that we don't have. So now what we do is we go to the equation for the vertical motion and try to find this t. Let's see what we get here. Plus g over 2t squared. What can we substitute? The final position, 1.5. The initial is 0. The velocity, this is the one that I said careful, because the initial velocity in the y direction is pointing up. According to my frame, up is negative. So I have to put here minus v naught. V naught is my unknown. But in the y direction, I have v naught sine of 10 degrees, right? So this is the component of the v naught. And this is just a number, you can put it there. Then the time that I don't have, my g is positive, so plus 9.8 divided by 2. So my g is positive. 9.8 divided by 2, t squared. So at first, you look at this equation, you get worried because you don't have v naught and you don't have time. So how can you solve it? But look that the equation in the x direction is very similar. You don't have v naught and they don't have time. So you have two equations, this one in the x and this is in the y. Now, so two equations, two unknowns that you can solve. You can solve if you isolate one of the variables from one equation. So what I'm going to do here is I'm isolating from the horizontal, for the equation for the horizontal motion, I'm isolating the time. So the time is 20 divided by v naught cosine of 10 degrees. Okay, so this t I'm going to substitute into my equation for the y equation. What do we have? We have 1.5, very good, equals 2, minus the v naught that we don't know, that we want to find. And then the rest is numbers. Sine of 10 degrees is just a number. The t, I'm not going to write t, I'm going to write the t that I isolated from the x equation. So I have here 20, which is just a number, divided by v naught that we want to find, multiplied by the cosine of 10 degrees. Okay, so you see everything here is numbers except for the v naught, and the v naught is up and down. We can cancel it. So everything here is just a number. Okay, what else do we have? Plus 9.8 divided by 2 and t squared. So t squared will be 20 squared, just a number, divided by v naught squared. Well, v naught squared is my unknown. V naught is my unknown. And then I have cosine of 10 degrees squared. Okay. Everything here is a number. The only thing that remains is the v naught. Now, so you have to solve this equation to finally find the v naught.